Hi everyone, today we will be talking about the vibration lab. In this lab we will do two experiments. One is the vibration analysis of free and cantilever beam, and here we will apply a couple of frequencies on the beam and measure the nodal displacement, and we will compare the results of experimental and theoretical. And in the second part we will do the damping analysis of the beam. So let's get started. So this is the beam. For the free beam we will consider the full length, and we are not supposed to have any support here in our free beam, but this is not the ideal case, so this is one of the uncertainty of our experiment. And for the cantilever beam we will consider this length, only the half length, where we have this is as our fixed end, but this will move in middle of the experiment, so it is also not the ideal cantilever beam. And then this is our function generator, and this is our amplifier, and this is our vibration generator. So in this experiment we will measure the position of the node point, and here we have 5 modes and 2 types of beams. So we will repeat the experiment for 10 times for different combination of mode and beam type. So this is how our data table will look like. So we have the natural frequency value for 5 different mode shape, and for the node number, if the mode is n, for the free beam the node number will be n plus 1, and for the cantilever beam, if the mode is n, then the node number is n minus 1. And we can also check it from the experiments also. And for the node position, we will get the node position from our experiment. And for the theoretical values, we have this equation. So this is the equation for calculating the node position for the theoretical part. So to start the experiment, we will click on the power button in our function generator. Here we can see that we have the range. So here we have clicked on the 50, so this means that the frequency range is 0 to 50. So here we can see that we have set our frequency to 15. So to change the frequency we can use this button or this one. For larger change we will use the coarse one, and for fine tuning we will use this one. So after setting up the frequency for the free beam, we have to on the amplifier. So here we can see that we have a signal clamp which we don't want, so we have to reset. And for that we can set the amplification to 1 or anything between 0 to 2, but we should not go beyond 2 because it will break the fuse. So to measure the nodal position, we can actually find it by looking at it, or we can also find it using something lightweight. So if we move it on this like this, we can see that in this point there is very less movement. So this is our one nodal point, and here you can see that this is our another nodal point. So we will mark down our nodal position, and after marking it we will calculate the nodal position from the end of the bar for the free end. For the cantilever beam we will do everything in a similar manner. We will just have to change the frequency here for the cantilever beam, and in case of measuring the nodal position we will measure the position from this end. So for the damping analysis, we will use the Signal Express to collect the data. So here we will click on the empty Signal Express project, and we will add step where we will click on accurate signals, then this one, and we will click on the analog input, and then we will click on strain. So here it is showing us the channels. So our strain gauge is connected to the channel 1, so we will click 1. Then we have to change the parameters here. So here the strain configuration is quarter bridge 1, and the gauge resistance is 120, and the initial voltage is minus 2.11 millivoltage, and the gauge factor is 2.075. So then we will click on the device, then we will click on strain calibration, and then next. So here we can see that the strain is in negative, so we should not get any negative values here. We need something which is closer to 0, because we don't have any vibration right now. So our beam has no vibration, so it should be 0. So we have to calibrate it. So it's still negative, so we will calibrate again. So it's something, this value is something closer to 0, so our calibration is successful, so we can click on finish. So right now our amplification is 0 here, so we will increase the value, so the beam will start to vibrate. So if we click the run button here, we can see the amplitude right now. These are the values. So if I change the amplification more or less, we can see the change in the graph. Right now we will be taking the data for the damping calculation, so we will click on the record, and here we have to select this one, and then OK. So after that, as we will be calculating the damping, we will make the amplification 0, and we will stop. Then we will go to the logs. This is our graph. So if we see a small chunk of data, this is the graph we should be getting, and we can see that how the amplitudes has decreased with time. So we will export all of our data from here. We have to click the export to clipboard or Microsoft Excel. So we have exported the data, and it will look like this. After exporting all of the data, we will take a small chunk of data, and from there we will take the cycle number for the small chunk of data, and the first sample of that small chunk of data we will consider that as the initial displacement, and the last one as the nth cycles displacement or amplitude. So from that we will use this equation for calculating the logarithmic decrement, and after that we can just calculate the damping ratio.